we are given the equation 5 to the power of 2x minus 26 multiplied by 5x plus 25 is equal to 0. And what we're asked to do is we're asked to find the value of x. And how we are going to approach this problem is, first I would like to use substitution. I would like to substitute 5 to the power of x for b. B is a random variable I chose to substitute for the value of 5 to the power of x. And what we're going to do is we're going to plug in b into this original equation. So b to the power of 2 minus 26 multiplied by b plus 25 is equal to 0. And so what we can do next is we can actually simplify this equation further. We can simplify this left side. So we can multiply negative 26 and b to create negative 26b. And we can leave the 25 the same, as well as b squared. And now what you see that we've created is we've created a factorable trinomial, b squared minus 26b plus 25. And so what we can do is we can just factor that out as b minus 25 multiplied by b minus 1. And that would essentially create b squared minus 26b plus 25 if you applied FOIL. If you applied FOIL. And so we have b minus 1 is equal to b minus 25 is equal to 0, right? And so now we can essentially, by the zero products property, we can say that b is equal to 1 and b is equal to 25 as well. So while this may seem like we have the solution, we do not have the solution to x. This is just the values of b. So what we're going to do is we're going to substitute these values back in for b. So we said that 5 to the power of x is equal to b. So what we can essentially do is we can say that 5 to the power of x is equal to 1 and that 5 to the power of x is also equal to 25. And so if you remember by our by how we approach logarithmic equations, what we'll have to do is we'll have to take the log. We'll have to take the log of each side of the equation in order to solve for x. And so essentially what we have is, after taking the log on both sides, we get log. Remember, when we take the log of each side, we have to take the base, so log base 5, and then multiply it by the exponent. Multiplied by x is equal to log of 1. And now what we can do is we can divide. We can divide by log of 5. Divide by log of 5 in order to get x. And after we divide by log of 5, after these logs cancel out, we get x is equal to log of 1 divided by log of 5. But at the same time, we can also simplify this. We can say that since log based, so of course log without a base is considered as log base 10. So log base 10 of 1 over log base 10 of 5. And so that's essentially equal to 0 over log base 10 of 5, which will therefore give us 0. So for 5 to the power of x is equal to 1, x must be 0 in this case, and we can actually see that it would yield 0, because anything a to the power of 0 will always be equal to 1, no matter what. Even if you have a billion to the power of 0, a trillion to the power of 0, it'll always be equal to 1. Anything to the power of 0 will be 1. And so now what we're going to do is we're going to solve for x in this second equation. So we will essentially take the log of each side once again. We'll have log of 5 multiplied by x. And that's going to be equal to the log of 25. And so once again we can divide by log of 5 on each side to get the value of x. We can cancel these out just like we did in this scenario, and then we get x. X is equal to log base 10 of 25 over log base 5. And so what that is essentially going to give us is let me calculate it. That is going to give us 2. That is going to give us 2. Because log base 10 of 25. So you can rewrite that as log base 10 of 5 to the power of 2. And that's essentially equal to 2 multiplied by log base 10 of 5. And we know that, log base 10 of 5 is equal to, it's equal to 2, essentially. And so we know that log base 10 of 5 is equal to 1. So essentially x is going to be equal to 2. And so really, essentially, there's 2 solutions to this equation. It's going to be x is equal to 0, and x is equal to 2. And so by using substitution to simplify this logarithmic equation, 5 to the power of 2x minus 26 multiplied by 5 to the power of x plus 25 equals 0, we're able to convert b squared minus 26 multiplied by b plus 25 equals 0 into a factorable trinomial, and then factor that out, get the values of b, plug it back in to equal 5 to the power of x, which we originally assigned the value of b2 over here in this specific scenario. And then after that we were able to take the log, find the actual value of x, and then get our answers, which are right over here. So that was another video on solving logarithmic equations in which we use substitution. I will also upload another video in the next couple days or so on solving logarithmic equations with substitution as well. Thank you, and please like and subscribe. Thanks.